Hello, geometry students. This is going to be our lesson for the week. Yesterday was the 4th, but you guys technically don't have class on that day, so we'll call it the week of May 5th. Can't believe it's May and we're getting out at the end of May, so in a way, the light is at the end of the tunnel, guys. Let's hang in there. What we are going to work on this week is something called the law of sines. And all we are going to do is I'm going to show you how to use the law of sines to solve for a side, a missing side in a triangle, and you'll see which types of triangles we can use that on. All right, so let's get started here. Here we've got an example where I've got a 40-degree angle, a 35-degree angle. I know one of the sides is 12, and I know that the angle across from 12 is 35. The big deal. You might be thinking, well, we could find the third angle of the triangle, and it would be 105, right? Because they all have to add up to, you know it, 180 degrees. The problem is, you wouldn't know kind of how to handle this situation because it's not a right triangle, okay? But in this situation, we can use what is called the law of sines. I know this looks a little bit crazy here. This whole bottom extended proportion that you see here, we're not going to use any of that this year, okay? I know I said we're not going to use it today. We're not going to use it this year. It's something I could show you in a normal classroom setting easily, but given our difficulty with remote learning, it's not a great situation. Let's just use law of sines to solve for a side, and we'll call it good from there, okay? Now, if you're someone who likes to ask, well, how come that works? Awesome, good for you. I'll give you a really brief explanation, but as you see in all caps at the top here, you do not need to know this, okay? So, if I look at my triangle here, and an important thing to note, sorry I haven't mentioned this yet, we are using, and I think we have covered this earlier this year, but I'll remind you, we tend to use, in math, we'll use capital letters for the vertices of a triangle or for a shape, and the corresponding lowercase letter for the side across from that angle. So you see you've got angle A, side A, angle B, side B, angle C, side C. Let's go ahead in here, and I'm going to just dot in a little perpendicular segment, perpendicular to AB at the bottom. We're going to call that X. So, and again, this is just the derivation. This is where the law of sines comes from. You do not need to know this. However, I wouldn't be doing my due diligence, not at least showing you for those that are curious. If I were to take the sine of A, remember sine is opposite over hypotenuse, sine of A equals x over b, just this little right triangle on the right. If I take this right triangle on the left here, then the sine of b would be x over a. If you solve each of these equations for x, meaning I multiply both sides by b here, I multiply both sides by a here, we're left with this equation. Divide both sides by b or divide both sides by a, and then we end up with this relationship, okay? It's actually a pretty simple derivation. You do not need to know that. What you do need to know, though, is how to use the law of sines. So we'll do a few examples together here. I'll give you one or two. I forget what I put in here. I think maybe we'll do two together, and I'll give you two to practice. But let's go ahead and label the angles of my triangle. And it looks here that x is side A, okay? Because we're solving for a side, I'm going to use my side relationship that we had on the couple pages ago. And just so you know, we're never going to actually solve things with two sets of equal signs. You don't do that in math. This is just to show you how all the sides and their angles across from each other are all related to each other. So if we're going to solve for x, we're actually just going to use this little proportion here. And now what I'm going to do is I'm just going to plug in to this thing here. Gonna plug into this guy. Yeah. Anyways, we're gonna plug in everything we've got. Well, side A is X. Angle A is 40 degrees. B would be 12, the side across from angle B. And angle B is 35. So all I've done here is I've taken this relationship and plugged in everything we know in the triangle. And now it actually becomes a really simple, straightforward math problem algebraically. Okay? If I just multiply both sides by sine 40, x is by itself. So you've got 12 sine 40 over sine 35, and that's actually something your calculator can handle in one smooth move. Here's what it looks like on a lot of calculators. You can just type in 12 sine 40 divided by or over sine 35, and we get 13.45. Okay, let's do another one together. So I've got a triangle here. I'd love to be able to use SOHCAHTOA, but I cannot because it's not a right triangle. We've got 63, 41. If we did triangle sum theorem, you'd get 76 degrees for the other angle. Okay, so let's set up a log sines problem. Let's solve for x here. So we're going to use this relationship. I'm solving for side C. We know side B. I know the angle at C and I know the angle at B. So let's plug all of that in. And here is the proportion that we now get. And again, a reminder, you should almost have your mouse on the pause button all the time. If at any time you need to pause and write down notes, that's great. You should be doing that all the time. You don't need to watch this lesson at the same pace at which I am giving it, okay? Take your time or go back through and watch it again and take your notes, whatever you want to do. But don't just feel like having this go through in real time once is going to be enough. Doesn't have to be. Multiplying both sides by sine is 63. And then I could put all of that into the calculator in one step. Here's what that looks like. And there's our answer. Looks like our units were feet, so let's make sure to leave our answer in terms of feet. And now let's have you guys try a couple on your own. Okay, I'm going to leave this on the screen for a second. Hit pause whenever you feel ready. And use the law of sines to set up a proportion and solve for side R. Okay? So your initial proportion should look something like R over the sine of the angle across from R equals 18 over sine of the angle across from 18. So R over sine 35 equals 18 over sine 107. One step to get R by itself, multiply both sides by sine 35. You can put this exact expression, 18 sine 35 over sine 107, into the calculator. And just another reminder, your calculator has to be in degree mode, not radian mode. Okay, if it says rad anywhere else, anywhere on your screen, it's probably in radian mode, and you're going to get a bizarre looking answer. So we can say that our solution is 10.80 centimeters. I'll give you one more for you to try on your own here. Go ahead and pause when you're ready and see if you can correctly solve for x. Okay. So you may have been thinking, well, shoot, I don't know the answer across from x, but you guys are pretty quick. You hopefully realize that you can solve for that angle because I know the other two angles in the triangle. So adding 41 and 103 together, I get 144 degrees for these two angles here. Subtracting that from 180 tells me my third angle has to be 36. So using the law of sines, we can set up this proportion here. X over sine of the angle across from x, 36, equals 12 over sine 41. If you're thinking, well, I didn't use 12 and 41, I used 17.8 over sine of 103, then you should get almost the exact same answer as well. I'm going to go through just using 12 and 41. I multiply both sides by sine 36. My calculator, I can type it in just like that, 12 sine 36 divided by sine 41. I get 10.75, and my units were meters in this problem. Okay? So, I am saying no Zoom session here right now. However, look for communication later. I may still try to host a Zoom session for periods 4 and for period 6 at the same time that I did last week. It just all depends on what's going on with our family. But I'm just going to go ahead and delete that right now. I'm going to say, please email if you've got questions. Stay tuned for our communication on whether or not we will be having a Zoom session. That's where it will have information on whether or not we're going to have a Zoom session on Friday. But I'm thinking we probably will, because this is sort of a new skill we've done here. You kind of were working on the same thing the last few weeks, so I'll probably try to have a chance for you to ask some questions at the end of the week. Please try to take advantage of that, okay? Take care, guys. Stay healthy. See you soon.